This is 1.7 part 2. If you did not watch part 1, please go back and do so. I talk about what is an inequality. I show you how to do interval notation and also how to graph on a number line. So in the second part, we're actually going to be solving linear inequalities. So the first thing we have to do is we got to get our x, and when I say x, our variable, on the left. And if we do that and we solve for x, or solve for our variable, then the inequality will tell us which way to graph, okay? So for example 1.7.1, solve each linear inequality, use interval notation to express the solution set, and graph each solution set on a number line. So we have a couple pieces for each problem. So the first thing we want to do is we want to get x, all x's on the left-hand side. But before I do that, I'm going to have to distribute this -4 and do multiplication over addition. So I do -4 times x, which is -4x, -4 times 2, which is -8. That is greater than 3x plus 20. So again, I'm trying to get all my x's on the left. So I'm going to subtract 3x off of the right-hand side and move it over to the left. And when I do that, I get -7x minus 8 is greater than 20. Now, again, I'm trying to keep that x on the left. Okay, so I don't want to move it. What I do want to move is that 8. So I'm going to add 8 to both sides. And to do that, I get -7x is greater than 28. Now I'm at my last step of solving. So I'm going to move this over here. So with inequalities, if you have a negative coefficient that is multiplied or divided by x, that would be the -7 in this case. When I divide it off, I have to change the direction of the inequality sign. Okay? All right, so I'm going to show you what I mean. So if I divide off the -7 off of both sides, this inequality sign right here is going to change directions because I divided by a negative number. Okay? So this becomes x is less than -4. Again, you only change the directions of the inequality signs when you have a negative coefficient of x that I'm dividing or multiplying off. Okay? And you only change direction of the inequality sign at the last step. Okay? Again, last step, and it has to be negative. If it's positive, if it's a positive 7x, I'd leave the inequality alone. I don't do anything. Only when it's negative. Okay? So I got this answer. X is less than -4. If I write this up in interval notation, then all my values of x are smaller than -4. So -4 is not included, and it's going to go, and if I look at the inequality, think of it like an arrow. It's pointing to the left. So it's going to -infinity. So in interval notation, it's -infinity to -4 with a parentheses and not a square bracket. Now, if I'm going to graph that, I'm going to put -4 here, and I'm going to just put -infinity down here. Okay, so if I'm going to graph that, I'm going to use an open circle. So let me use a different color here. Open circle on -4. And then I'm going to run this line down. Okay, so I'm just going to make this a little bit darker. So it's -4 going to -infinity. Again, look at the inequality sign. It's telling you to graph to the left. Okay? All right, guys. So we did first question. I answered the question. I solved the linear inequality. I wrote it up in interval notation, and I also graphed the solution. So let's go ahead and move on to this next one. 3x divided by 10 plus 1 is greater than or equal to 1/5 minus x over 10. I'm going to clear out, and I put cheer. I'm going to clear out the fractions. To do that, I'm going to multiply everything by the LCD, lowest common denominator. So if I look at that, I have a choice of 5 and 10. I have to use the lowest common denominator, which would be 10. Okay, I'm going to multiply everybody by 10. So I'm going to put these 10s in parentheses. So every single value gets multiplied by 10. I don't want to skip anything, so I'm being very careful. Okay, so it looks like that. Okay, so when you multiply everybody by 10, now you can cancel stuff out. So 10 divided by 10 is 1. So I'm left with 3x plus 10 times 1 is 10, greater than or equal to. 5 goes into 10 twice, so 2 times 1 is 2, minus, now these 10s will cancel each other, and I'm left with just x. So when I clear out the fractions, I have 3x plus 10 is greater than or equal to 2 minus x. By the way, if you clear out the fractions, you have to multiply every single term by the lowest common denominator. You can't do half of them and just leave the other half alone. You have to multiply them all. So that's why I write out that step showing I multiplied everything by 10. Okay, now I have to isolate x on the left-hand side of the equation. Okay, so what I'm going to do is going to add x to both sides because I'm moving this x over to the left. So 3x plus x will give me 4x. Okay, so 4x plus 10 is greater than or equal to 2. Again, I'm trying to isolate x, and I'm going to leave it on the left-hand side, so I'm going to move the 10 over. So 4x is greater than or equal to negative 8. Okay, I'm at my last step. Now this time around, my coefficient of x, or the number in front of x, is positive. So when I divide by 4, I do not have to change the inequality sign. I only change the direction of the inequality sign when that number is negative. Okay? So it's positive, so I'm not going to change it. So 4 divided by 4 over x is greater than or equal to negative x over 4. Okay, when I do this, I get x is greater than or equal to negative 8 divided by 4, which is negative 2. Okay, so I got my solution, but it says I have to write that up in interval notation. In interval notation, this is telling me that all my x value are greater than or equal to negative 2. So negative 2 is my smallest value. And I was going to do a number line there, but let me not do that. So negative 2 is included, right, because there's an equal sign. And it's going to positive infinity. So again, if you look at the inequality sign, it looks like an arrow pointing to the right. So when I graph this, I'm starting at negative 2, and I'm going to graph to the right to infinity. So graphing this out, negative 2 is going to be a closed circle because it's included, going to positive infinity. All right, so I did the interval notation, I did the graph, and I solved the problem. Okay, next one. C. I'm going to put a line here so we don't get confused. All right. Okay, so C says I have 4 times 2x plus 1 minus 2 times 3x minus 5 is less than or equal to 2x plus 14. Again, I'm going to go ahead and distribute. So I get 8x plus 4, and this becomes negative 6x plus 10 when I distribute. is less than or equal to 2x plus 14. Okay, again, I want to get all my x's on the left-hand side. That's the deal. But before I do that, I'm going to combine like terms. So 8x minus 6x is going to give me 2x. So 8 minus 6 is 2. Okay, and the other like term that I see is positive 4 and 10. So 4 and 10 is 14. So when I combine like terms, I get 2x plus 14 on the left-hand side. And that's less than or equal to 2x plus 14. Now what I'm going to do is I'm going to get my x's on the left-hand side and everything else on the right. But if I stop for one moment, I'm going to see that the left-hand side and the right-hand side are exactly equal to each other. When that happens, the answer is all real numbers, or in interval notation, negative infinity to positive infinity, because every single value will work when I plug this in. But let's say you didn't see that. So if you didn't see it and you kept on moving, when you go to subtract off the x's, you'll know that they cancel out on both sides. And I get a statement that says 14 is less than or equal to 14, which is a true statement. 14 equals 14. Okay? So if I graph this out on the number line, and I'll do this in black, it's going to be the whole entire number line, right? Because it's all real numbers. Okay? So again, when you get a true statement like that, or a number equals the same number, the answer is true, then it's all real numbers. Okay, thanks for watching 1.7 part 2. I'm going to pick up on this next part with 1.7 part 3 in the next video. Thanks for watching.